All right, welcome back to EMR and EKS video series. I'm Damon Cortese, your host, and today we are going to wrap up with optimizing Spark on EKS. And so most of the rules for optimizing your Spark jobs are going to remain the same, but there are some quirks about configuring Spark jobs on Kubernetes. So we've got a script that takes some weather data from the NOAA Integrated Surface Database, and it calculates the top wind speed per day in 2021 for a given geo-bounding box. The biggest thing about optimizing Spark anywhere is really understanding your workload. So, if you're reading in one 50 gig gzipped file, you can only do that on one executor, right? But if you're reading in tens of thousands of tiny files, you want a lot more cores to distribute the reading across. And so that's what we're talking about today, is how to look at your job and configure it on Spark on EKS and what things you have to kind of keep in mind. And so we're going to look at that for this job. At the time of this writing, there's about 13,000 files in the bucket that I'm going to be reading, and it's about 5.5 gigs in size. And so what we're going to do is we're going to take this job. I'll go ahead and get it spun up, and so we can get that started and talk through what's going to happen while it's running. So I'm going to copy this over, paste it into my console here, and this will spin up a Spark job on EKS. And we are being very explicit about our executors and executor cores. And so what we're doing here is trying to figure out what the right balance is between the number of executor instances and the number of cores per instance. And so the other thing to know is the number of cores you can specify is really dependent on your node groups that you have available to you. So if I go over here in my configuration and I look at my two node groups, I've got this compute and this generic one. The compute one is a set of, what is it, C5 XLs, I believe it is. Where is that? Yeah, there we go. C5 XLs. So if we look at, C5 extra large, that's going to be 4 CPUs, I believe. Yep, 4 vCPUs. So I can't have more than 3 instances or three cores selected here. I can spin up as many instances as I want to, but I can't have more cores than 3. And that's because as part of the EMR and EKS runtime, we request 0.1 core. And so if I requested 4 cores, that'd be 4.1. And so we wouldn't be able to, we wouldn't be able to get any specific node that had more than 4 vCPUs. So that's just something to keep in mind. As you are running jobs, you do have to have a little bit of awareness of what node groups are running under the hood. I also pulled up the Kubernetes dashboard because this gives me a little bit more of a real-time insight into what's happening on the cluster. And so I can actually see, if I go here, I should be able to go to jobs, and this is where I can see all the detail about that job too in this Kubernetes dashboard. So I can see the labels that are on that job, I can see the images associated with it, and if I click through to the job, I can also see just a whole bunch of other very detailed information about it. So the other thing I like to do is I like to look at the pods, and I'm staying in my namespace here, my Decort demo namespace, and you can see I've spun up my driver pod and my executor pods, and that is across 3 different instances, or 3 different nodes. And so we can kind of see what's going on there in terms of both CPU usage and memory usage and what the state is of those pods. The nice thing is the logs, if you want, they can be logged out to S3 or CloudWatch like we showed earlier in the series, but I can also look at logs if I have access to the Kubernetes dashboard here. So that's something that is kind of nice too, is you can kind of see, you can essentially get access to the container logs running inside Kubernetes too. But that's only if you've got this Kubernetes dashboard installed and you have access to it and all that kind of fun stuff. And so what we see is, I'm going to go back to this overview. You can see we spun up a couple new instances, probably because this C5X large already reserved, and then the resources we requested 2 cores and 2 instances, or 2 executors. And so in the Kubernetes dashboard, you can see we've got our 2 executors here, and each of those required 2 cores, and so we spun up some new instances in order to be able to handle that. I have the cluster autoscaler running here, and so you can see the cluster autoscaler is triggering scale up of that, and so that's something that is really nice to have. You probably have that in your EKS cluster already if you have a production EKS environment running, but something good to keep in mind. So this job, this takes a little bit to run. But what I'm going to do while that's running is I'm actually going to change my configuration a little bit. So what I'm going to do is, let's see, I'll take the shell command, bump up the executor instances. And so I'm going to take this shell command, I'm going to bump this up to 5, and we'll see what happens. So I can submit this job at the same exact time. Go ahead, submit that job. We have a new job running in the cluster. And what's going to happen is that job will get submitted. Again, the cluster autoscaler is going to need to trigger here before we get stuff spun up. But you can see we've already got this job submitter here. So that's going and submitting there. And we can see it already knows that we don't have enough CPU. So the cluster autoscaler is going to identify that, is going to scale up, and we'll see what happens there in just a couple of minutes. And so there's a lot of different ways that we can tweak this, right? We can change the executor instances, we can change the executor cores, but we know that we can only go up to 3. We can also change the amount of memory associated with the job too. So there's a lot of different things we can do here. The other thing that we can do is there is the dynamic resource allocation. So let me pull up our EMR EKS best practices document. This is a really awesome resource that we've put together. It's open source on GitHub, so if you want to contribute to it, by all means, please do. But we have a performance section on there, and we talk about dynamic resource allocation. And so this is something that's really, really interesting because you can actually just say, hey, I want you to figure out how many resources you need, spin up, whatever that means, and just take care of it. We can, of course, specify an initial set of, min and max or initial executors, but it's really nice to be able to say, hey, spin up more executors as you need them. And so that's something that we'll experiment a little bit with as well at the end of this. That job is still running. It's still spinning up some new containers. You can see they're in pending status. Some are still creating. And you can see all these executors spinning up here. We've got 1, 2, 3, 4, 5, and I believe that is what I configured. Yeah, we configured 5 executor instances, so you can actually see 5 new pods all spinning up here. And some of them are running on the same host. Some of them might be running on different hosts. If I go back to the cluster dashboard here, you can see that we've got a lot more. We've actually got 2 pages now of different instances, and so this is just spinning up and spinning up. So it's really, really fun to kind of watch that go. This job does take a little while to run. Takes anywhere from about 5 to 15 minutes, depending on how many executors I have. So what I'm going to do is I'm going to let this run for a little bit. I'm going to cut out, and then I'm going to come back in with our dynamic resource allocation. I had those 2 jobs running. I actually just went ahead and canceled them because it was going to take quite a while to run. So I went ahead and canceled them, and now we just see our Jupyter Enterprise Gateway running here. I want to go back to EKS because now I started up all those nodes, and you can see I've got a whole bunch of compute nodes here that are just ready and waiting. So what I'm going to do is I've got 1, 2, 3, 4, 5, 6, 7, 8 compute nodes. I'm going to do this dynamic resource allocation. What I'm going to do is I'm going to say run with dynamic allocation. So everything's the same. I'm going to enable dynamic allocation. I'm going to start with 20 initial executors, and we're going to see what happens there. So let's go ahead and start this job run. And now we've got our job over here on EKS, that's or EMR, that is submitted. And so the nice thing is that dynamic resource allocation is going to keep an eye on the job, and it's going to say, okay, I see that you've been running for a long time. I see that you need more resources. I'm going to go ahead and add more executors. And so that's one of the really nice things about the dynamic resource allocation is you don't know exactly, if you don't know exactly how many executors you need, it's totally fine. You can go ahead and use the dynamic resource allocation, and if your job is on running and it continues to need more executors, Spark will go ahead and create those for you. And there should be about 10 of them because what we did in the code, or sorry, 20. There should be at least 10. I don't know if we'll get 20 right off the bat because we don't have quite that many nodes running. So the cluster autoscaler might need to pop back in here and say, hey, you requested too many. I'm going to spin up more, but we should have about 10 of those running already. So that's pretty cool. That's getting spun up. And if we go into the incomplete applications on the history server, what we should be able to see is there's that Spark job. You can go over here to the executors. You can see we're running 10,000 tasks or so, and you can see these different executors here. So we've got 10 executors up and running. You can actually see how many tasks have been completed on a per executor basis. So this is really good to see. Do I have a whole bunch of tiny little tasks running on each executor? And if I do, it's good for me to be able to like add more executors and spread out that load. If I have, 4 executors running 2 tasks and 4 more executors running no tasks, that means I haven't really adjusted my load very well. And so we see pretty good distribution here because we see all these different tasks spread pretty evenly across these executors. Each task is running really quickly in a matter of seconds, and so that's pretty decent as well. If I refresh this page, we'll probably see more executors start to pop up. So you can see we've actually got 31 now, so it looks like the dynamic resource allocation is already kicking in and spinning up more executors, which is really awesome because it looked at the plan for this, and it was like, hey, you are going to need some more help here. So we've got almost, I think, 30 executors now, all trying to run tasks. And you can see the earlier executors have run more tasks. If I go down here, the later executors don't have quite as many tasks as they're running, but that's normal. It's still trying to spin up more executors, but I have a feeling this is going to be done here pretty quickly. But this is awesome because we had this warm pool of nodes. It was able to provision those really, really quickly. It did try to add another one. You saw it ticked up to 13 there, so it's still spinning up another one. But I think this is going to be done really, really soon here. So if I look at my job, you can see, yeah, it's still got a few more tasks to run for the last stage of it here, but it already read in all of the files that it needed. It's done most of the processing, and it looks like it is actually done. So, what earlier was taking upwards of 11, 15 minutes, it's been 4 minutes since we submitted that job. We are already done. So that's where the dynamic resource allocation came in kind of handy, as well as the fact that we already had 12 nodes that had been provisioned. So this is one reason why maybe you spin up your cluster in the morning, spin it down at night. But this is where dynamic resource allocation comes in too, because if the job does need more resources, it can go ahead and ask for them. And with the cluster autoscaler and EKS, it can go ahead and provision them. So pretty awesome to just have this dynamic environment for your EMR on EKS Spark jobs. That's all for now. Thank you so much. Can't wait to do more of this. Bye-bye.